this is week 1 of algebra. Okay. So first, let's just do a quick review. So we're talking about what is a variable, right? So in math, a variable is a letter which represents a number value. So I have an example over here. So we have 2x plus 4, and we can plug in 2 for x, for example, and we get that 2 times 2 plus 4. 2 times 2 is 4, plus 4, which is equal to 8. Actually, so a variable can represent any number value. So you can choose which value x can represent here. Okay, so let's go to the next slide. Okay, so I have a practice problem over here. And actually, I want you to type in the chat what you think the answer is. Okay, so everyone's saying 12, which is the correct answer. So 12 is the correct answer. Okay, so let's go to the next slide. Okay, so the first topic that we're going to tackle here is our polynomials. But before we start learning about polynomials, we need to understand what a term is in algebra. So what is a term? So if you look at our picture over here, it's easier to explain if you can see it. So you can see that our terms are our basically individual expressions, and they're separated by our minus sign or our plus sign. Okay, so we can see that our terms in this polynomial over here, we have 5xy squared, so that's one term. We have negative 3x, that's our second term. We have plus 5y cubed, that's our third term. And even this negative 3 at the end, that counts as a term. Okay, so we have 4 terms in our full polynomial over here. Okay, so I have another practice problem over here, and I want you to type the answer in the chat. Okay, so the answer is 4. Only 2 people answered. Okay, now 3 people answered, but yeah, I think most of you know the answer, which is 4. So the answer is 4. Okay, so now let's look at what a polynomial actually is. So a polynomial is an algebraic expression with many terms. So we have some examples over here. So we have 2x squared plus 4x plus 5. We have 5x to the 4th plus 3x cubed minus 7x squared plus 9. And we have 9x squared minus 8. And obviously there are a lot more examples of polynomials that we can have. Okay, and this is really important. So we have to understand what's not a polynomial. So we have a 6x to the negative 3 power plus 5x minus 8. So the reason why this isn't a polynomial is because we have an exponent with a negative, we have a variable with a negative exponent over here. So we have this x to the negative 3 power. we have this x to the negative 3 power, and that is the reason why this expression over here is not a polynomial. Okay, and then we have 5 times the square root of a plus 9a plus 7. So the reason why this isn't a polynomial is because we have the square root sign, right? So we have the square root sign over here, which means that it is not a polynomial. Okay, so the next example, we have 8a to the a power minus 9. So this isn't a polynomial because we actually have a variable in as our exponent over here. So that is why that expression isn't a polynomial. And finally, we have this 4 divided by x. So the reason why this isn't a polynomial is because we actually have a variable in the denominator. So if you look at these polynomials over here that are examples, we can see that all the variables are basically in the numerator. So we can say, for example, 2x squared plus 4x plus 5 is the same thing as 2x squared plus 4x plus 5 divided by 1, right? And we can see that all our variables are actually in the numerator. So same with these other two polynomials over here. But here, we have a 4 divided by x, and our variable is actually in the denominator. And that is the reason why 4 divided by x is not a polynomial. Okay, so now let's look at our classifications for polynomials. So we classify polynomials by the number of terms in the polynomial. So an expression with one term is called a monomial. So if you didn't know, mono equals 1. So that's an easy way to remember that. So an example is 2xy. So as you can see, there's no plus sign or equal sign. Or sorry, there's no plus sign or subtraction sign. It's just one term over here. So a polynomial with two terms is a binomial. So bi means two, right? So a binomial has two terms. So an example over here is 2xy plus 5x cubed. Okay. A polynomial with three terms is called a trinomial. So tri means three, right? So a trinomial has three terms. So we have over here, we have 2xy plus 5x cubed plus 8y cubed. So that's an example of a trinomial. And then an expression with many terms is a polynomial. So a polynomial is more of like a general term. It's not specific to like the exact number of terms an expression can have. So a polynomial is just a general term, and usually it means a polynomial, or sorry, an expression with more than one term. So for example, a binomial or a trinomial. So an example here is, it's the same example as before, 2xy plus 5x cubed plus 8y cubed. Okay, so let's go to the next slide. So we have our third practice problem. So I want you to type in the chat, which of the following are binomials? Person in the chat has the correct answer. Okay, so the answer is A, D, and E. Okay, so someone said A and E, but I think they forgot that D is actually, so D is a polynomial over here because, so even though it's just x plus y, we can say that our coefficients for x and y are basically 1, right? And we can say that x is to the first power and y is to the first power. So that's why D is also a polynomial over here. And then someone else said A, C, D, and E. But if you look at C over here, this isn't actually a polynomial at all. So it's kind of like a trick question because we have a y to the negative 9th here, right? So that is what makes it not a polynomial. And yeah, so A, D, and E are the correct answers. Okay, so now, review or an intro. Okay, so I'm sure many of you know how to graph in the coordinate plane, so this might be a review to some of you. But for those of you who don't know, so this is called the coordinate plane. So we have our x-axis, this horizontal number line is called the x-axis, right? And our vertical number line is called the y-axis. Okay. And when we're graphing equations, so x is going to be our input basically. So x is going to be our input into the equation, and y is going to be our output. So for example, let's say we have y equals 2x. So if you look at our equation over here, y equals 2x. So if we input, so x is our input and y is our output, right? So let's just say that x equals 1, for example. So 1 is our input. So if x equals 1, so if we plug in 1 for x here, y would be 2, right? So 1 is our input and 2 is our output. And if we look at our graph over here, we can see that point plotted. So we have 1, 2. So obviously the x coordinate is the first number and the y coordinate is the second number, right? So we have 1, 2. So let's just use another input. So let's say x equals 2. Then we have 2, 4, right? Because we plug in 2 for x, we get 2 times 2, which is 4. And we can see that in our graph over here. So basically this line has all the points plotted for this equation over here. So all the inputs and all the outputs, which is why you see this continuous line over here. So we have a continuous line over here of all the inputs and outputs for x and y. Okay, so let's go to the next slide. Okay, so now we're going to be talking about functions. Okay, so a function is a math equation that takes an input, which is x, and produces an output, which is y or f of x. So this notation over here, you pronounce it as f of x. Okay, so let's look at our basically our number machine over here. So let's look at our first example. So we see that we have 2 as the input over here. This is our function, so this is what is happening to the input. And then this is our output over here. So we have 2 for the input, we're adding 2 to it, and then we're getting 4 as our output, right? So when we're talking about functions, our x is our input, and we're doing something to that input. So we're basically doing something to that input, right? So we're adding something or multiplying or subtracting or dividing something. And then our output is our y basically, or our f of x. So f of x or y, so these are both notations you can use to represent the output basically. Okay, so in this case, as you can see down here, our f of x or our y is equal to x plus 2. Because we have we have 2 as our input for x. We have our plus 2, which is our function, which is what is happening to the input. And we have 4. So we're adding 2 to x to get our output over here, which is why y is equal to x plus 2. Okay, and another really important thing that you have to know about functions is that for it to be a function, so the input has to produce only one output. Okay, so if we're putting in one input over here, it has to produce only one output. So it can't produce like 2 or 3 outputs. Then it wouldn't be a function. And also another thing I want to point out is that sometimes we can have like multiple different inputs can produce the same output basically, but that would still be a function. Okay, so let's go to the next slide. So these are some examples of functions. So we have f of x equals 2x, y equals 4x squared plus 5x plus 9, f of x equals 2x cubed. Y equals 4 is a function also. So y equals 4 is just a horizontal line, right? So y equals 4 is a horizontal line, so that's also a function. And f of x equals 6. This is also a function over here. And these are some examples that are not functions. So we have x equals 6, x equals 90. Basically, if you have x equals any number, then it's not a function. So actually, let's go to our graph and let's see why that's the case. Okay, so let's just say we have x equals 5, for example. So we said this isn't a function, right? So the reason why this isn't a function is, so we have 5 as our input, basically. But as you can see here, 5 can lead to many different outputs. So it can lead to, it can lead to 2, it can lead to 4, it can lead to 6. So it basically can lead to an infinite number of outputs over here. So that's why x equals 5 isn't a function, because our input is 5, but our output can be like literally any number, any real number. So yeah, that's why x equals 5 isn't a function. And let's say we have y equals 2x plus 5. So this is a function actually, because we can see that, let's just say we have one input. Let's just say we have 0 as our input. We can see that it only leads to one output. So we have 0, 5, right? There's only one output there. So that's why this is a function. So you can see that if we go through a line over here, we can see that every input has only one output. Okay, so now I'm going to teach you a way that we can identify functions by looking at their graphs, basically. So this is called the vertical line test. So when we're looking at, let's just say we're looking at, a random equation. Let's just say, for example, we have y equals x, for example. So let's say we have y equals x. So the way we can test to see if this is a function is, we can just imagine like a vertical line. So we can imagine a vertical line that's passing through this graph over here. So that's passing through this graph. And if at any given point, if it only passes through one point, basically, then it is a function. So we can imagine a vertical line over here. And if it's passing through our graph over here, we can see that at any given moment, it's only passing through one point. So if we look at x equals 5, so if we apply our vertical line test, we can see that when the vertical line comes to x equals 5, we can see that it's passing through basically infinite points, infinite y values. So that's why this isn't a function. Okay, so that was a vertical line test. Okay, now we're going to be talking about types of functions. So there are many types of functions that you will work with in your math journey. So we have our linear function over here, f of x equals mx plus b. So we have our quadratic function. So f of x equals ax squared plus bx plus c.
One second. Yeah, I got
We have our
it.
cubic function.
I know, 1 second.
F of x equals x cubed. We have our square root function, our exponential function, and we even have our trigonometric functions over here.
Here you go.
So yeah, there are many more functions that you're working with in your math journey. Okay, so now we're going to be talking about, we're going to be doing some basic function transformations. So when we're looking at functions in their graphs, we can basically, so if we change the equation, so you can see it, if we look at our table here, if you change the equation, we'll see how our graph changes relative to our change in our equation. So let's go to our graph. Okay, so let's say, for example, we have y equals 2x, right? So let's just say, for example, we have y equals 2x. And let's actually change this equation. So for example, let's add 1 to this equation. So we have y equals 2x. So let's add 1 to this equation. So we're going to add 1. And we can see how our graph changes. So this is our original equation, y equals 2x. So this red line is our y equals 2x. And our blue line is our new equation, y equals 2x plus 1, right? So we can see that when we add a 1 to our graph over here, our original graph actually climbs up by 1 unit. So it jumps up by 1 unit. So we can see here, for example, so in our red graph, we have the point 0, 0. And in our blue graph, we have the point 0, 1. Let's take another example. So in our red graph, we have 2, 4. But in our blue graph, we actually have 2, 5, right? We have 2, 5. So we can see that so y equals 2x plus 1, it says 1 unit, basically 1 unit above. Our y value is going to be 1 unit above our y value for y equals 2x. Okay, and if we, for example, let's just say we have y equals 2x minus 1. So y equals 2x minus 1. So we see that our blue line actually climbs down by 1 unit. So in our red graph, we have 0, 0, right? But in our blue graph, we have 0, -1. So in our red graph, we have 2, 4, for example. And in our blue graph, we actually have 2, 3. So yeah, our y value for our blue line is 1 unit below our y value for our red line. Okay. And another basic function transformation that we're going to look at is when we multiply -1 to 2x over here. So -1 times 2x is just -2x, right? So -2x. And so what happens over here? So what happens over here is basically our line is kind of reflected. So it's reflected over the x-axis. So actually another way so an easier way to think about this is, let's just say we have f of x equals 2x, and let's say we have y equals negative f of x. So we can see that our blue line is basically just a reflection of this red line over the x-axis, right? Because if we look at our equations over here, so f of x is our output, right? It's our y value, it's our output. But what we're doing is we're multiplying -1 to that. So if we have 2, 4 over here, our output is going to be multiplied by -1. So we're going to have 2, -4 over here. So we're going to have 2, -4 over here. So in our red line, we have, for example, 5, 10. So in our blue line, we're actually going to have 5, -10, right? So our blue line, so we can see that our blue line is basically just a reflection of our red line over the x-axis, right? So it's a reflection over the x-axis. Okay. Okay, let's look at another transformation. So let's say we have let's say we have y equals x. And now let's say we have y equals x minus 4. So our red line is y equals x, right? And our blue line is y equals x minus 4. So you can see over here, so this is actually pretty interesting. So even though we have x minus 4 over here, so you would think that the blue line would be to the left of the red line, right? But actually the blue line is 4 units to the right of the red line. So why does this happen? So why is this the case? So this is the case because so we subtracted 4 from our x value, right? We subtracted 4 from our input. What that means is that our input has to be four numbers greater, basically. So 4 numbers greater for us to get the same y value as our original equation. So for example, in our red line, if we input 5, our output is 5, right? But if we look at our blue line over here, so now since we subtracted 4 from x, so now our x has to be 4 numbers greater than 5 to get our same output of 5. So we can see that in our blue graph we have 9, 5, right? So that's why when we have an x minus 4 over here, our whole graph basically shifts to the right 4 units. Okay. Okay, let's go back to our presentation. Okay, so that's the end of the lesson basically. So these are our topics that we learned or reviewed today. So does anyone have any questions? You can say them, you can unmute yourself and say